write the program for those different levels of abstraction levels. Now, if you all are ready with the software and everything is fine, then we will start. Otherwise, I will take 5 minutes time to clear the doubts of yesterday's class. Or if you have any license issues also, I hope everybody completed it. Now, still, if you have the license issues, let me know so that I can help you out for 5 to 10 minutes, and then we will start the class. No queries? Aruna ma'am?
Hello.
Yeah. Now let us start.
Yes, sir.
No
Yes, sir.
having queries? Or you would like to wait
queries.
one more time?
You start the session.
I would like to unmute yourself and let me know means queries so that I can proceed to the next.
Hello. If anyone is having the queries, like
Hello.
you may ask the speaker.
Now you can post it in chat box.
Unmute
Hello, sir.
yourself and then let me know.
Good afternoon,
Hello
sir.
is in chat box.
Good afternoon. Good afternoon.
So actually, it is asking simulation top module name. What should I type, sir?
I did not get your query again. Come again.
While I was running the simulation, it is asking simulation top module name. Specify top module.
Actually, you have to select. You have to select that whatever you wanted to run as a top model. If it's happening, then you have to. I will show you here. Let me open my tool.
Mahendra, there is a question in the chat box. How you write new programs in existing projects and how to simulate? Hello?
I will let you know all those things today.
Okay.
Yeah, I'm seeing these charts and I will let them know. All they can. Are you hearing any of my background noise? My voice is clear? Is my voice is clear? Anyone
Yes,
unmute
yes,
yourself
your
and
voice
then
is
let me
clear.
know.
Your voice is clear, Mahendra.
Thank you. Now, are you able to hear any background noise of mine? No, no. Ramana sir?
Yeah, I didn't get any background noise, but little something, if I observe a lot, there is a sound like fan, sound of fan.
Okay, okay then. Now, for the now here, see this is the top module. Right click on it, and then you have to set this as the top module. See, at times some of the models cannot be set as the top module. Here, that 3 dots indicate top module.
Please
Okay,
share
if
your
that is not
screen, sir.
happening, and you have to write
Your
set as
screen
the
is
top
not,
module, and then you do simulation.
Dr. Mahinder, your screen is
Not
not
visible.
visible. Not visible. You are
Okay.
present in this. Yes, yes.
Why I already
Once again, you. Off the presentation and again
Yeah, I'm doing
represent. That's better.
I'm redoing it. Yes, yes. Now are you able to see my screen?
Yes, yes. So you have to open the working
Yeah.
window.
Now are you able to see my screen? After tool.
No.
No, sir.
No, no. Your screen is not visible. No.
Why already? One minute, let
Kindly
me
recheck once.
reshare it.
Okay.
Are you able to see my screen now? Hello.
Your screen is not visible. You are presenting, but your screen is not visible.
Okay, let me log out and then re-log in. Okay.
Yeah.
Give me 1 minute.
bathroom key.
Able to see my screen?
Not yet. Not
Hello.
visible. Not visible.
Now I'm
Not visible,
presented it.
Mohinder. Have a multiple
Not
logins?
to all the participants, but no, it is not. I have multiple
No,
logins.
sir.
Have a check
Same
it.
login only.
Please log out completely, then you join. That's better.
That I have done now. That right now, just now.
Again, the same. We are presenting to everyone, but we are please share the actual window. What you want to present, Mr. Mahendra? Once.
Hello. Are you able to hear me? Now are you able to see my screen? Hello.
Mahinder, your screen is
Hello.
not at visible. Mahinder, your screen is not at visible to us.
I already shared it.
So, Mahinder, I will call you personally. Please switch on the phone. Okay, right. One second.
Yes. Now are you able to see my screen?
Yes, sir.
Ramana sir. Now are you able to see my screen?
Yes.
Yes.
Yes. Yes. Please open your PPT
Okay.
once.
Thank you. Yes. Are you able to see my PPT? Hello.
Not visible to us. Screen is only visible to us. Yeah, now it is open. Now
Not
it is
PPT
right.
visible.
Yes, now it is visible. Now it is visible. Right.
Now I have opened tool also. Is tool also visible?
Yes. Yes.
Participants, somebody unmute yourself and then let me know.
So please respond in the chat box. I request all the participants respond in the chat box. Mahendra sir, the PPT is visible now.
Yeah.
And we can also tap the
Okay.
yes, visible.
Yes. First, I will take the query. Now here, whenever you are getting the message saying that select the top module, what you have to do is, now are you able to see my screen? Fader is there. Now how is the module? Right click on that and then set as top. This you have to do. Set as top.
Mahendra, you are
In future also you may get these type of errors. Hello.
the PPT window is open, visible to us. That window, please tab. PPT window is visible to us. That Vivado window is not. Yes, now it is visible. Now it is good. Yes. Yes, now is okay.
It is visible.
Yes, now it is visible. Mahendra sir. Right.
Now participants are unable to unmute themselves.
They are in mute already.
I want some participants also to speak. Please, the organizers, if possible, you can give the rights to participants to unmute themselves.
Sir, we are able to see, sir. Please continue.
Yeah, thank you. Now here half adder. Okay, right click on the half adder and then set this at the top. So that problem will be resolved. I hope you understood. Now in future also you may get this kind of errors. Okay, that can be solved like this. Okay. Thank you. Now let us move to any queries. If you have any queries, please unmute yourself and then speak. Otherwise, I will continue with today's. I will give you 15 to 20 minutes, some theory concepts, and then I will tell you what are the abstraction levels we will be using and how to do programming for them. Unmute yourself, then tell me. Good to go. Any participant?
Sir,
Yeah.
how to define module in project settings? Can you explain that once again?
How to define module in
Project settings.
I will
So
tell
how
you.
to do that
Anyway,
define
means whenever
module?
I will come to the yes,
Okay.
that I do. Okay, now let us understand few concepts and then we will see the programming again. Okay. Now we will be understanding the concepts of continuous assignment, structural modeling, and the Verilog HDL test bench. How to write the Verilog HDL test bench, and then we will go for implementing this continuous assignment, that is data flow modeling, and then structural modeling and test bench. These things we will see today, and tomorrow I will explain the concept of behavioral modeling and how to design the sequential circuits. Okay. Now before going to that, I would like to give you information of. Are you able to see my screen?
Yes.
Yeah. Now here in Verilog HDL, we can design the systems, that is digital systems, by using 4 coding styles. We can call those coding styles as levels of design description. We can call those coding styles as levels of design description. Now here we can follow the behavioral or algorithmic level description. That is one coding style. Next one is data flow coding style. Third one is gate level or structural level coding style. Fourth one is switch level. And these coding styles can be called as. Please, somebody is unmuted. Organizer. Yeah. Now first let us understand these 4 coding styles. What are the 4 coding styles? And then we will understand how to write the programs by using these 4 coding styles. Now first, as I said, behavioral or algorithmic level coding style. Here what we do, we describe the digital system by using the algorithm, or we write the program by considering the behavior of the system. in general. Actually, how you write the C programming, the same way we will write the programming here. In the C program, we know only constructs. You cannot understand what is the structure of that particular application. You will see behavior of the application, and then based on the behavior of the application, you can write the program. Now next, data flow modeling. In the data flow modeling, what we do is we derive the Boolean equation for the behavior of the system. We can derive an equation for the behavior of a system, and then we use that Boolean equation to represent the behavior of the system in the Verilog HDL. These are the two in general we use. Third one is gate level or structural level. This can be used for interconnection of the individual modules. Now, if you take the arithmetic logic unit will have the adder, subtractor, multiplier, divider. Now we design all these modules, adder, subtractor, multiplier, divider separately, and then we integrate them together. There we need to use the structural modeling in order to interconnect the various structures together. There we use the structural. That means here we will be understanding the concept of how the structure of the system, based on the structure of the system, we can design, or based on the gate level diagram of the design, we can write the program. We can call that as the structural or gate level program. Fourth one is switch level. In the switch level, we interconnect the transistors together in order to develop the gates. Now these are the 4 levels of design description what we use. First is behavioral level, where we use the behavior of the system to describe the HDL code. In the second one, we derive the Boolean equation for the behavior of the system, and then we use that Boolean equation to design to write the code. And in the third one, we understand the gate level structure or system level structure of the design, and then we interconnect all of them to complete the behavior. That is what the structural. And fourth one is switch level. Now let us see in one shot how these things will be done, and then I will explain you in detail about each one. Now look at this. Now for explaining these concepts, we will be using the multiplexer, that is 4:1 multiplexer. I hope everyone know the 4:1 multiplexer, what that do. That will have 4 inputs, 1 output. That will have 4 inputs, 1 output, and 2 select lines. And based on the select line combinations, we can connect any one of the input out of 4 to the output. This mux is the data selector, where one of many inputs are connected to the output based on the select lines, right? Now that is the behavior of multiplexer, and here we have considered 4:1 multiplexer for understanding. Now let us look at the 4:1 multiplexer internal structure. Now if you look at this, you can see clearly truth table. If both are 0, 0, I0 is connected to Y. If 0, 1, I1 is connected, 1, 0, I2 is connected, 1, 1, I3 is connected. Now this is how we interconnect, and this is the gate level design, gate level diagram of multiplexer. This is the behavior of the multiplexer. Now as I said, we derive the Boolean equation for this behavior. This is the Boolean equation. Now if we use this behavior directly to describe the HDL code of 4:1 multiplexer, then we can call that as behavioral design or algorithmic style, coding style. Or if you use this Boolean equation to write the HDL code, then we can call that as data flow level modeling or data flow coding style. And if you use the structure of the gate level design, then we can call that as structural modeling or structural style of HDL code. Now this, and fourth one is if you interconnect the transistors, then that is switch level. But most of the cases we will not use the switch level. In most of the applications, you will be starting from either behavior or Boolean equation or gate level. Okay, these three widely we can use. So look at the behavior. Now here this is the behavior, and here we have written the program by considering the behavior. Okay, later in detail I will explain you. Just for your understanding, I am showing you this slide. Okay, to understand the abstraction level or coding style, how we do. Here we described the behavior. See here, 0 0. If S is 0 0, then I is connected to outputs. 0 1, another one is connected, like that. Here we have seen just behavior. But if you look at the second style, that is data flow style. In the data flow style, what do? We will use the Boolean equation. Whatever Boolean equation you have seen here. Here we will be using the Boolean equation for the data flow modeling. That is what data flow coding style. Okay, I hope you understood. This is the logic diagram, and from this we understood that there is 4 NAND gates, 2 NOT gates, 1 OR gate is required, and then we have used that effectively. Now let us look at the structural level. In the structural level, what we see, we look at the gate level design, and then we will go for interconnect the gates here. This is how we can interconnect the gates. But in detail, I will explain you in next concepts. But as of now, you can understand that there are 4 coding styles: behavioral, data flow, structural. 4th one is switch. Switch one means here we can interconnect the transistors. Now here to design the NAND gate, transistors are interconnected. Now these are the 4 coding styles we can use, and in some textbooks they used to write it as the abstraction levels. Coding abstraction levels. Why? Because now look at this. At the switch level, we design the logic gates, and logic gates are used to design these systems, and systems are used to logic gates are used to describe the individual modules, and individual modules are interconnected as bigger system. That's why this is abstractions. Okay, from the switch level to the behavior level we can use. Anyway, I hope you understood. There are 4 coding styles. Now let us look at each coding style. Okay, any query here? Am I audible? Please, anyone unmute yourself and then let me know. Am I audible? And you have any queries?
Yes, sir, you're audible.
No queries from the audience? Now these are the 4 coding styles we will be understanding hereafter. Out of which behavioral is suggestible highest abstraction level, and the switch level is lowest abstraction level. Okay. Now from this we can understand transistors are used to interconnect the logic gates. Logic gates gives the Boolean equation. Boolean equation, by using the Boolean equation we can design the behavior. Now let us look at the coding styles. Now this is one coding style. As I said, data flow modeling. In the data flow modeling, we use the Boolean equation. As I said, we use the Boolean equation. Now here we can use the operators and assign statement. Here in the data flow modeling, the Boolean equations are implemented by using the keyword assign. And this assign is continuous assignment, and the exact name for this assign keyword is continuous assignment. Why they are calling it as continuous assignment? Whenever we write the keyword assign, here if you look at this example assign, it continuously monitor the equation. Continuously monitor means if there is any change happens at the input, immediately that change will reflect at the output. That is why we can call this assign construct as continuous continuous assignment construct, and this assignment construct continuously monitor the changes at the input. As soon as changes happens at the input, immediately that reflects in the output. That is why that continuous name is tagged to the assignment. Now this is the syntax of the assignment, assign, and here delay, we can put the delay, but this delay is optional. If you put the delay, that indicates that there should be some delay should taken to assign input to the output. That means whatever right hand side data is there, that right hand side data will be reflected to the left hand side data after the certain delay. If you would like to keep the delay, you can. Otherwise, no, not required. But in real cases, at times there is need of putting the delay in order to synchronize the flow, in order to synchronize the operation of the digital system. At times there is a need of stopping some of the signals or delaying some of the signals. That's why they have given the option of delay. Okay, now I hope you understood the syntax of assign, and already we have used this in the yesterday's program also. After this, we need to remember some rules. Okay, LHS, that is left hand side, must be a net data type. That means this side, whatever is there, left hand side, that is must be net type, not register type. Always active, because of that is continuous assignment, that will be always active. And right hand side will be either register or net. Here right hand side there is no rule. Okay, that way either register or net, or some call also no problem, some structure also no problem. But left hand side, the variable or identifier should be net type, net data type. Okay, now this is the example. Already we have seen 2:1 multiplexer example, 2:1 multiplexer example, and here we have used the assign construct, and we have used the Boolean equation. Now here, can somebody tell me, is it is data flow modeling or behavioral modeling? Anyone unmute yourself? Or you can chat in, I can see. Now here it is not data flow modeling, it is behavioral modeling. How to represent the data flow modeling? For select, not of select dot a plus, here that indicates or select, your dot is equal to end operation. Now this is the Boolean equation. You know that Boolean equation for the 2:1 multiplexer is, if A and B are the inputs and select line, S bar dot A plus S dot B. Okay, that is what. Here dot indicates the end operation. S bar means negation. Here this is not required. Now, do you understand how we can implement? This is the Boolean equation of 2:1 multiplexer. Now we have implemented this by using the Boolean equation. Now let us see another example. Now let us look at the decoder. Now this is the decoder, and this is truth table, and Boolean equation of decoder is, when decoder is, what is the behavior of decoder? Whenever inputs are 0 0, D naught is 1, right? If 0 1, D1 is 1, 1 0, D2 is 1, 1 1, D3 is 1. Now this behavior is implemented here in terms of Boolean equation. Now D naught is equal to, now let us look when D naught is 1 here. Okay, D naught is equal to enable and not of A1, not of A naught, right? Not of A naught. Now this is the Boolean equation for D naught. Simply here there are 4 outputs. For 4 outputs, there are 4 equations, 4 Boolean equations are derived, and we have used the assign statement. Whenever you are doing the data flow modeling, we can use the assign, and then we can write the Boolean equation. Now that is what the Boolean. Now that is what the data flow modeling, where we use the Boolean equation of a system. Now look at another example. Now here we were using logical operations, okay, and not everything, okay, to implement. At times, if you want to perform the addition operation, okay, again we use the addition operators. Plus is the adder operator, and the star is multiplication operator. We use those operations. Now here also we have used assign. Why? Because here we are implementing the equation. We are implementing the Boolean equation. Here also we are implementing Boolean equation. Here that's star plus and asterisk. Asterisk is multiplication, plus is addition, will be performed on the digital data. A and B are the digital data here. It cannot take the analog data. Okay. Now this is another example how to use the assign. Here also in both the cases we have used the data flow modeling. Now these are the 3 examples data flow modeling. Now I want you to implement all these 4 programs: multiplexer, decoder, adder, and multiplier. 4 after our session. Okay, whenever we enter into the hands-on practice session, I will ask you to implement all these things. Now is it clear? Any query here? Now I'm going to the next coding style. If you have any query related to the data flow modeling, I'm ready to take it as of now. No queries? You can chat here if you are unable to unmute yourself and do the chatting. Now anyone unmute yourself and then let me know whether to go next. I want little kind of interaction. Hello? Are you able to hear?
Sir, no doubts, sir. Please proceed. Another
Yeah, thank you.
level of.
Now have you noted down? Otherwise, take the snap of this. Why? Because these programs you have to practice. I request all of you take the snap. That is print screen. Take the print screen and store in somewhere in the Word document, and then you can practice all these things. Okay. Now let us go to the next concept, that is data flow modeling. Sorry, structural modeling. Now in the structural modeling, we can interconnect the multiple modules or multiple gates together in order to describe the behavior of a system. Now we can call the concept of interconnecting different modules together as module instantiation. Here the structural modeling can be done through the concept of module instantiation. Okay. Now here module instantiation is having the syntax. Now that is, what are components we are going to interconnect? This is the component name of the component we need to give, and then delay, like assignment statement we have given, but this delay is optional. This delay is optional, and then instance name. Now I will let you know what is the difference between component name and instance name. But as of now, understand there are 2 names we need to give. One is component name, which is implemented. Instance name is for identification. And inside the list we can give the port list. Port list means how we can do mapping the ports from one to another interconnection. Okay, that means if you want to interconnect to two, what do we need to do? We need to interconnect one signal from first module to the another signal of second module. Okay, there should be an interconnection between two modules. How those interconnections are defined can be expressed by this port list. There are two methods to express the port list. I will let you know in the next slide. As of now, you can understand that there should be component name, there should be instance name and port list. These are the must and should in module instantiation, and the delay is optional. As I said here, module name indicates the module whichever is lower level component. Now, as I said, the example of arithmetic logic unit. If you want to construct arithmetic logic unit, there should be adder, multiplier, divider, subtractor. Now, these are the four lower level components, and if you interconnect all of them, that gives you arithmetic logic unit. And at the end of this training program, you will be doing that also. Okay, next, delay is optional, but if you want to keep the delay while assigning the data or while passing data from one module to another module, if you would like to put some delay, you can put the delay here, so that same delay is applied for the ports while passing the data. That means if I assign 5 nanoseconds, now that after getting the data across the ports, that wait for 5 nanoseconds and then pass the data inside the module. Next is instance name. This is unique name given to individual components for identification. Okay, and port list is the list of ports or signals which are used for the connections between the modules. Now, I hope you understood how module instantiation can be done. Now, look at these here examples I have given you. Now, this is the program module gates, and here I am taking two inputs and I am going to implement all the logic gates. Actually, Verilog HDL is having the primitives. We can call these all the logic gates as the primitives, and these primitives will be implemented directly without writing the program for the individual codes. But later I will explain you how to write the program for the individual lower level components. Now, look at this. There is buffer keyword. Okay, buffer is the primitive. Okay, buffer un. Now, here component name is buffer. Buffer is the component name. U1 is instance name. I am giving the unique name for this. Instance name is U1. And then ports are C. C is output port. A is input port. That means A will be passed to C. Since it is the buffer, just pass the data from the input to the output. Right? A is input, C is output. Similarly, NOT, where B is input, D is output. Now, here module is NOT, U2 is the instance name. Like this, all the logic operations are implemented. Okay, now we can use this coding style in the structural modeling of Verilog HDL. Okay, now AND operation require two inputs. So A and B are the inputs, E is output. R requires again all except these two first two, remaining all requires two kinds of inputs. Okay, that will be passed to the next. Okay, now let us move to the next. This is very easy, and these all very primitives are available in the Verilog code itself. That's why here no need to describe the behavior for the AND gate. Automatically, if you write like this, automatically AND operation will be performed. But in some of the cases, there is need of describing the code for AND operation. Now, look at this. How we can connect the ports. Now, as I said, if you want to connect one port to the another port, there is need of following certain rules, right? Now, here first look at the type of connecting the ports, that is connecting instantiation ports. Now, here we can connect the ports in two ways. One is we follow the same order how that port is having the input order. Otherwise, we specify the name. This signal should be assigned to this signal. Like that, we can specify the name. This signal of top module should be assigned to this signal of lower module. Okay, that is what by name we can assign. There we need to specify the names also. Okay, now here you have to remember few points while doing port instantiation. Look at this. Now here while port instantiation we can use all the nets only. You cannot see here registers. Reg is the data type used for storing the data. Net is the data type cannot store the data, just that pass the data. And here interconnections, whatever we are using, those all interconnections are just wires which carry the data from one module to another module. That's why all the signals what we define here are names, nets. Now look at this, the behavior of half adder, how it was done. Now previously we have seen the OR gate and gate. Now in the data flow modeling, how we do represent this? By using the Boolean equation. But here in the structural modeling, we will represent the behavior of the half adder with the help of the logic gates. Right? Now here logic gates are interconnected. Now look at this. A and B are the inputs. A and B are the inputs. S is output. Now XOR. XOR performs the operation on A and B and assigns the data to the output. Now for this instance name is U1. For next logic gate performs the carry operation. For this instance name is U2. Now here two logic gates are interconnected together to perform half adder operation. Now here two logic gates are instantiated, but here method what we followed is order list. We have followed the order list. Just we have kept order of output first and then first input, second input. Same for the second also we have followed the order of the ports. Okay, now this is one way of representing. Now for understanding this concept clearly, let us look at another example, that is full adder. Now all of you understood the concept of how to design full adder by using two half adders. How to define or construct the full adder by using two half adders. Now you can see here this diagram where two half adders are connected together in order to describe the behavior of full adder. Now look at this. This is the half adder having the inputs A, B, sum and carry. Now first what we need to do, we need to define the half adder. In the previous case, there are primitives available, XOR and AND gates. These are the primitives already available in the Verilog HDL. That's why directly we have used. But here we need to describe the behavior of the lower level module also. And here in this case, low level modules are half adder, high level module is full adder. Why? Because we are constructing the full adder, that is higher level module from low level modules. Okay. Now here low level module is half adder, high level module is full adder. Now let us look at how the higher level module, that is full adder, is interconnected. Now as you know, there are two half adders where first half adder takes the inputs. The A of the full adder is connected to the A of the half adder. B of the full adder is connected to the B of the half adder. Then sum of the half adder is connected to A of the next half adder. Now carry of first half adder is connected to OR gate through the signal called C1. And second half adder takes this data which is connected from the half adder as one input and the Cin as another input, and then produces the sum. And now this sum, whatever sum is produced at the second half adder, that is the real output. And carry of the second order is given to the OR gate, and combination of carry from the first half adder and the second half adder will give you the carry of full adder. Now this is the construction. Now here two half adders are interconnected to describe the behavior of full adder. Now let us look at the structural modeling, how they have done it. Okay, now the sequence what we can follow for ports is this one, always outputs first, Okay, and then inputs. These are the three inputs. Now outputs are SC and inputs are ABC, ABCN. Okay. Next, wires. As I said, there is need of intermediate wires to interconnect. Now we have taken S1, C1, C2 as the wires. Wire means it is not storage element, it is net. As we have seen previous slide, we need to use the nets to interconnect, right? Here we are using the nets only. So S1, C1, C2 are defined as the net. Okay, now these are the nets which carries the data from one lower level module, that is half adder, to another half adder. Now look at the cell instantiation. Cell instantiation states that interconnection of two lower level modules in order to give the behavior of higher level module, that is interconnection of two half adders to give the behavior of full adder. Now look at this here. As I said, there are two methods we can follow. Here it was mentioned the order half adder. HA1 is the instance name and this is the module name. Okay, lower level module name, this one, and this is instance name. This is, you can give any name here, but unique name you need to give. Then order. See here in the half adder, first I have written the carry, next sum, after that inputs. So here also we need to follow the same order. So the C1 is connected to C, S1 is connected to S, A is connected to A, B is connected to B. That is what A. Here A is this A, right? Here A is this A. Okay, this half adder is having A, B as the input, A and B as the input, S and carry as the output. Okay, S carry is carry, SC is carry, S is sum. Now this is the order what they have followed or what we are following in this half adder. Okay, so here also we need to follow the same order. So carry which is generated from this half adder is connected to the C1, that means this one. Okay, that means whatever half adder carry appears here, that is here, that is connected to C1. Next, whatever sum is produced here, that means sum is this one. Okay, that will appear in S1, that means the sum is connected to the S1. Then A and B are the inputs, this A and this B. Okay, now full adder AB is connected here, here. So this A is connected to this. So this A here is connected to this A, and this B is connected to this B. Okay, now this is one way of defining. Now see, since here there are two half adders, for one half adder we have followed one first method, that is by order list method. Port connections can be defined in two methods. One is ordered list, second one is by name. Now we have seen the ordered list, that means same order we need to follow here inside the brackets. Okay, whatever order we have followed for the lower module, same order we need to follow. Here for the another half adder, we have followed the second method, that is names. Now here there is no order is followed. If you look at this, first A, here first dot A states that half adder. Okay, whatever half adder we have written, first outside the bracket ones are half adder ports, inside bracket ones are the connections what we are connecting to this. Now here for the A, S1 is connected, that's why for dot A indicates A input of the half adder, is connected to S1. Inside the bracket we can put which signal is connected to the port of half adder or port of lower module. Then dot B, now this is the B, this B is connected to C in, so inside the bracket we have written the C in. Next, sum, S is connected to S. Now carry, this is dot C is the carry, dot C carry is connected to C2. Now see here we have not followed any order, even though order is first carry sum AB, but here that order is not followed, but we have defined the names Whenever we define the name, automatically S1 is connected to A, Cin is connected to B, S is connected to S, C2 is connected to C. Okay. If you don't want to follow this method, and you can follow the order. Whenever you are following the order, we have to follow the order which is defined for the lower module. And here in the higher level module, we can define the signals of the higher level module in the same order how we wanted to pass the data to the input. Now I hope you all are good at the C language. In the C language also, whenever you are passing the functions, what do? You can put the same order. Okay, so int A, if we write similarly in the function also, there will be same data type that we considers. Same here also. Whatever data we need to assign for the half adder ports, okay, those are assigned here in the sequence. Now these are the two methods what we can follow, but you feel which method is comfortable to you? Following the order is comfortable, or following the names, means assigning the pins or interconnecting the one signal to another signal through their names is easy. Okay, you can follow as your convenience. Okay, but any one can be used, or both also can be used, but my suggestion is follow any one. And expert states that the second method, why? Because here names we are defining so that you don't confusion, or you don't get the confusion. But if you are clear with the designs, then ordering also easy. Why? Because here these many signals are not required to keep. Here we can put what all the signals are connected in the order. Now this is how we can interconnect the logic gates, or we can interconnect the modules. Now we have seen the best example of interconnecting two half adder to describe the behavior of full adder. Okay, now I hope you are clear with this concept. If you have any queries, I will take it up. After that, we will start programming. Any queries here? Now the same concept we will use for writing the test benches. The test bench also, what we do? We define this. Okay, and here we can consider the, anyway I will explain you, don't get confused here. Now if this concept is clear, then I will explain you how to write the test benches. The test benches are also very easy, and then we will go for the coding. Any doubt? Take the snap of this also. Now you have to type this. Take the snap of this. No queries?
No, sir. You may proceed, sir.
Okay, thank you. Now next one is writing the test benches. Now look at this. Here we are writing the test bench for the half adder. We are writing the test bench for the half adder. Now look at this. This is the, here also we have followed the method of structural. A half adder. Inputs are A and B, outputs are SC. Now XR. See here we are not taking the primitives. We are defining our own XRs. Okay, XR1 and 1. And the instance name is U1, U2 for these two. And the sequence is ABS. AB are the first, we have followed the inputs first and then output. You can follow this method also. Again inputs first and this one. And here we have made the logic for each gate. Here I have used the two gates, XR and a gate. So we have defined the logic for both of them. Now this is another method of describing the half adder by using the logic gates defined by HDL language. Now look at this half adder test bench. Now to test this, we can follow this method. Now here the test bench, you cannot find any ports here. Why? Because this is the test bench. where we can generate the stimulus. Stimulus states that different input patterns, what we follow. Okay, the stimulus is used to give give as input and verify the output. Okay, now I will let you know how to write. Now whatever inputs you want to give, we need to define them. Okay, always the inputs will be defined as the register. Why? Because we need to store the value and then pass to the half adder. Now it is like there is main program. From the main program we are passing the data or values to the sub program. Now in C language also you can follow two methods to pass the data. One is call by value, another one is call by reference. Am I right? You might have studied these two concepts, call by value and call by reference. Here in the structural modeling also, now first one is call by value, second one is reference. Okay. Anyway, let us look at the test bench. In the test bench, what you can see? Half adder. Now this is the structure. For this half adder, we are passing the data. Okay. So half adder of A, this is dot A. Outside the bracket indicates the port of the half adder. Now it gives you some error. Why? Because here I kept the capital H. Okay. Now no problem. Half adder. Here DUT is the name, instance name, and here instead of previously we were given U1, U2 like that. Here I am putting DUT. Why? Because design under test. DUT states that design under test. Right? Dot A is the half adder input. To that we are giving the A. We are giving the A what we have defined here. Similarly, dot B, that means B of the half adder is assigned to B what I have defined here. Now dot S is assigned to S. That means after computation, output is passed to this, and this S will appear in the waveform. Okay. Again dot C, that is carry output is connected to C of this. Right. Now A and B are the registers. They are kept inside. Okay. That's not a problem. Now we use the construct initial. Initial means it will be run only once. If you want to run once, then we can use the initial begin. Inside the initial we can define the value. Initially we have given A0, B0. Next A0, B1. Next A1, B0. Next A1, B1. Now these are the values we given. Now this is the way of defining the binary values. This represents the size. This is radix. Tick 1 tick B0 indicates that 1 bit of binary and its value is 0. If you want to define 4 bits, here I can say 4 tick B, 4 zeros or 4 ones or combination of 4 bits I can write here. Okay. Now this is one standard what we have to follow, but because of lack of time, why? Because we have only 2 hours per day, means I am not explaining all those concepts. If you want, I have made some videos for my students. I will give you those videos. Okay, links are available in Google Drive. I will share the Google Drive link to you. You can watch those videos. There you can understand, okay, all these concepts, how to represent the numbers, all these things. Okay. Now this is the test bench what we have written for the half adder. You can take the snap of this also. Why? Because you have to practice this after my explanation. Keep the snap and then save somewhere. Next test bench we are writing for the multiplexer. Now this is the behavior of the multiplexer. Here we have followed the behavioral modeling, and then this is again mux 2:1 DU to design under test. A of mux is connected to capital A. Now see here, names are different. Okay, there here in the half adder I kept the same names here also, but here I kept the different names. Your wish, you can put the different names. Different names in the sense I have used here the capital and here small. Okay, dot A in bracket this A, dot B in bracket this B. Okay, this is how. That means we are passing signals from this test bench to the module to test it. Okay, here also we have followed the structural modeling. Always structural modeling we can use for interconnection of the logic gates, and also put that circuit which to be tested under the test bench. Okay, in the test bench also we follow the same concept. Now this is the calling the main program. Sorry, in the C language you can call the functions from the main program. Same. Now this is the main program. It calls the function, that is module, to test, and values will be passed here. This is call by value or call by reference method we can follow. Okay. After that, initial begin, and here we give the value. First I am giving A0, B0, SEL 0. So output Y should be, whenever SEL is 0, A is connected. So 0 is connected to Y. Similarly, some more values. But here, instead of giving the more values, we will be using always statement. See here, and one more construct is used here, that is always. This is again another keyword. Initial is one procedure block. Inside the procedure block, all the statements are sequential. Sequential means first this will be executed, this will be executed, this will be, all these are executed sequentially. Okay, always block also another sequential construct, where again sequentially everything will be executed. But here I have written multiple always. All the multiple values will be, sorry, all multiple always statements are executed parallelly. Inside the always, all the statements are executed sequentially, but all always constructs are executed parallelly. Remember this concept clearly. Inside the always construct, all the statements are executed sequentially, but all the always constructs in the module are executed parallelly. That means this executes parallelly, this executes parallelly, this executes parallelly. But inside the always, that means later you can understand. But here only one statement we kept. But if you have kept multiple statements, all those multiple statements which are under the always construct are executed sequentially. Now here in this always statements, what we are doing, this is repeated. Okay, first A, if we give the A0, now after 6 nanoseconds, A is inverted. A becomes 1. After 6 again A becomes 0. After 6 nanoseconds again A becomes 1. Like that we are changing the values, and with the delay of 3 we are changing the B value. That means for every 3 B value will be changing, for every 6 nanoseconds A value will be changing, for every 5 we are changing the select lines in order to fetch the different inputs, different combination of inputs to the design. Now this is another way what we follow to generate the bit patterns or input patterns to test the design. One is, as I explained here, manually we can write all the patterns. Now if your combination is more, then we can choose the method of automatic generation. For the automatic generation, this kind of techniques will be used. But by practice you can understand all the concepts. But as of now, you can understand that we can use the time delays to generate different values at a different intervals. Okay, and for more test benches you can follow this website link. Here you can find the more information on test benches, how to write the test benches. Okay, for different digital systems you can find direct codes. I have taken these 2 codes also from there only. Okay, for our demonstration purpose. Now I hope you understood the test bench concept also. Now we have seen the data flow modeling and structural modeling, and how to implement this structural modeling to write the test benches also. Now I hope this information is enough as of now. Now I want you to start the programming. If you have any queries on these concepts, I will explain you. After that, we will go next. Now, this is another example. Take the snap of this also. So you can implement this also. Structural modeling. For the structural modeling, implementation of 4:1 multiplexer by using 2:1 multiplexer. Okay, this is interconnection. Here also we have used 3 multiplexers of the same 2:1, and M1, M2, M3 are the instance names. And here we have followed sequence of ports or order of the ports. Okay. Here I followed input first, then output next. Here also same, inputs first, then output. And here we have taken the intermediate signal W0, W1. We have defined them as wire. And here you could see 3:0. That means this is the vector. Yesterday somebody was asking how to define the multiple signals. Okay, this is the vector. If you don't have the vector, I, simple I. Since we have written here 3 down to 0, it gives us the signals I0, I1, I2, I3. I0 means I in the bracket 0. I1 means I in the bracket 1, like this. Here S, S1, S0. Okay, S0, like this. You use the square bracket, like how you are using in the C language. In the C language also you use the same way. I hope you all are good at C language, since you are approaching the placements year. So you will be good at the programming skills, and now this will help you again to enhance your programming proficiency. Okay. Now this is another way of doing cell instantiation or module instantiation. Any queries here? Now let us start the programming. Now we have seen data flow modeling, structural modeling, and test benches. Now with this, we will start the programming. Any queries till now? If you have any queries, please unmute yourself, then let me know. Otherwise, you can put in the chat box.
In the chat box, they are asking for PPT, sir. Post the PPT in the Google Classroom.
PPT is good, they are asking, but they are not asking the PPT. They are saying
PPT is good. Try to post the PPT in Google Classroom.
Yeah, I will post it. PDF of this I will post it. But I say my suggestion is take the snaps, okay, whenever you get it. Anyway, actually I made some videos because of this COVID-19 pandemic, and I made some videos for the students. I will share those videos also, okay, with you, and you also go through them. Okay.
Okay, sir.
Now, any queries here? If you have any queries, we will take it up. Otherwise, we will start with programming.
Sir,
Sahid,
someone is asking, Rajendra, is it the test bench program is separate for different models?
different models in the sense?
A behavioral model, data flow model, structural model. I don't think so, sir.
No,
It's
no,
the
no.
same.
No. It is same. It is same. The test bench is the way of inputting the data to test the HDL code. Okay. And what kind of code we write? See here, one more thing you need to remember. As I said, we can follow 4 different methods, 4 different coding styles to describe the behavior. And whatever style you follow, final behavior of the system is same. Multiplexer can be implemented by using the behavioral, data flow, or structural. We have seen the multiplexer clearly in 3. One I have used the equation, another in some another place I have used the behavior of the multiplexer. In recently I have shown the structural modeling also. Wherever the multiplexer is implemented, behavior of multiplexer is same, but coding style different, but its functionality will be same.
Sir, is there an online source we can run these test benches?
I did not get you. Online?
Online EDA tool where we can run the test benches as well.
There are video tools are there. As I shown you the one website. There you can find most of the test benches.
No. Sir, he's asking like we can run any test benches in the online
Online simulator.
No, there are test benches in the online.
test benches,
Online simulators are
online
there.
simulators.
But since you are describing your behavior, okay, always suggestible to write your own code. Online tools, they generate the patterns. Okay, those patterns you have to input to the design through writing the test bench. See why? Because here you will be following different uh, sequence for the ports, all those things. But online people may follow some different. But patterns, what online tools generate, those patterns will suits you. So the interface, what I can say. 1 minute, I will let you know. Now here this interface, this is the interface between, see, because of this only data whatever you are defining here, this will be passed to this. Now this interface you have to create, and here the patterns you can use from the online. There are online tools, they can generate the patterns. But there are no online tools to generate, okay, test bench for your design. For your design, you only have to write the test bench, but in the test bench, this part, up to this part you can do. Then body of the test bench, you can take from the online. Okay,
Thank you.
thank you. Now let us start. What would you like to start now? Now already data flow modeling, we yesterday also we have done. This is what data flow modeling. Now I want you to quickly write the program for decoder by using the data flow modeling. Decoder program I explained to you. Now this is the decoder. Actually, first if possible implement the multiplexer. Take this program, multiplexer, implement the multiplexer, and then decoder. And then we go to the structural modeling practice. Okay. Okay.
Yes, sir.
Now all of you start the programming. Now shall I repeat the same concept yesterday whatever I said? Now for the new, I hope, I don't think so there is no new persons, all are yesterday's only. But now thing is, if you got confused yesterday, okay, I will explain you again today to understand it clearly. Always go to the file, start new after opening the file. Next, here give the name. Since I'm going to implement the mux, I'm giving the mux name of the constructor is mux 21, that is indicates 221. Now see what method I am following is, just I have copied the code, means it is not suggestible. If you copy the codes from here to there, you cannot learn much. But before copying, understand the code. Okay. And then RTL project, ensure that you have to select the RTL project. Then next, here you have to define the inputs by creating the file. Okay, create the file. Otherwise, you can skip it here, and then go to the next. Either you can add the file here, or after creating the project also you can add. Any method you can follow. Okay. Now I will tell you the concept of creation of the file after creating the project. Now next, here you have to select the board. I suggest you to go to the boards instead of the parts. Then select which board is available, but I don't think so these all boards are, but some of the colors are having the Zinc boards and Arctic 7 boards. Finish. Now you will get this window. Here you get the summary of your project. Now next, right click on design sources. At the left hand side, you will be finding the sources. In the sources, right click on design sources, and then you can find the option add sources. Here choose the option add or create the design source. Next, now you can add, create the file here, and you can give the name mux underscore 21. Okay. Next, finish. It will ask you the inputs. If you want to do, while if you are copying the file from somewhere, no need to create this. Then say OK, and after this you will get like this without the ports. Without the ports you can write. Since I have copied already the program, I will paste that here. Okay, remove that, whatever module is there, you can paste the program whatever you copied from there. Why I am telling you this copy method means to avoid the time now. Why? Because I am not physically present with you. But you have to type. And already I have shared these files with you in the Google Classroom. Now after this, save it. After saving, automatically errors will be generated. Now here, good thing of this Vivado is no need to test the errors separately. As soon as you save your file, automatically if there are errors, errors will be thrown here. Now there are no errors, but I will make the error. Okay, I will remove here SC. I am removing. Now I will be saving it. After saving, I will get the error. If I don't get the error, that is minor error, but that error will be thrown at the time of simulation. Because since this is a very minor error, so it is not showing that error. But at the time of the simulation, that will be shown. Now I will try another way. I think it is throwing the errors at the time of simulation only. But at times you will get the errors here also. Okay. Now all of you completed up to this. Already I given you this file here in the Google Classroom. Go to the Google Class. In the lab one, you can see. In the lab one, you can see here. Sorry, day one material. Okay, this is having the programs. Today I will also upload some more materials for you. Day two programs I will upload now. Now you have got another few tasks today. Now today there are 6 tasks to do. Okay, yesterday 3, today 6, total 9 tasks you can do today. But I will explain you the concept and then I will hand over to you and you have to practice it. And if you face the problem, tomorrow we'll discuss it again. Okay? Are you able to hear me? All of you done up to this?
Yes, sir.
Now after this, what you have to do is simulate.
మరి రెండు ఉంచుకో దీంట్లో పెట్టు. పాలు తాగేటప్పుడు అప్పుడు తిన్నాం దీంట్లో పెట్టుకో.
Okay, now give A some value, force the some value, force 0, I am forcing first, and then B I am forcing 1. Then select initial, I am giving the 0. Can somebody tell me if I give the select 0, what will be the output? Here I given 0 to the A, B is 1 and the select is 0. Then what is the expected output?
It's A.
A value, A is 0. Okay. Now look at this, whether you got the same or not. A is 0 and output is 0. Okay. Now I am making A1. If I make the A1, now output should be 1. Why? Because S is 0. Whenever S is 0, A is connected. Am I right? Now see, output is following the input since select is 0 I given. If I give the select is 1 now, then somebody tell me what will be the output? If I give the select 1. 1, yes, great. B value will appear at the output. Now see. Now if I make the 0 B, then output will be 0. Yes. Now it is done. If you have completed it, then I will tell you next concept. All of you completed? If you have any queries, you can post in the chat box. Okay, frequently I will see. Yes. Saga done. Any more? Yes, we're also done. Okay, good. I hope you are enjoying the programming. Now I given you many tasks. You have to do all these tasks, 9 tasks. If you open the individual files, then you can find complexity of each file. But you have to understand. Now, whatever basic knowledge I given you, this is enough to understand. Okay, you should not depend for everything on me. Okay, I given you the concept, and I explained you how to use the tool. Now you can do the miracle, and there is Google for you. Everything is available in the Google. Only thing you need to know how to access the tool. Now I explained you the concept of accessing the tool or using the tool, and then I given you the basics, how to write the program, how to test it. Now this is more than enough to explore the concepts of Verilog HDL. Now let us go to the next. Now here you could see the RTL, right? This RTL, here you can find the schematic. This is another important thing. If you click on the schematic, it will give you the gate level view of this particular program. What is the program we done? Multiplexer. Now it will show you the RTL view. RTL means register transistor level view. That means how the data is passing from input to output. The data flow view you can see. So after completion of this, you may close the simulation window. Then look at this. Now this is the view you can see. Select line. Select is connected to the both. Okay. Now A is connected to this and this one. But while connecting the select, that is inverted. That is what the gate level diagram what you have drawn while studying the digital systems, digital logic design or switching theory and logic design or digital electronics. Different universities follow different concepts for them. But here this is the thing what you can see. AND gate. Right? Now see, this was not given by us. We given only English letters. But here you can see the gate level netlist. Okay, this is what RTL view. Okay. Do you understand how to see the RTL view of your design? Whatever design you describe, you could see the RTL view of that by clicking on the schematic. Okay. Now after this, you can synthesize it. Synthesize means conversion of your logic into the gate level netlist. Just this is the RTL view only we have done here. Okay. Then if you want to see the time, how much time it takes to pass the data from input to the output, or if you want to see the power, how much power is consumed, everything, that is possible only after synthesis. If you want to synthesize your code, double click on this. Otherwise, right click and then choose the launch synthesis. Otherwise, double click. And here you can see the status running the synthesis, this design.
Sir, some student is asking simulation taking long time. What should I do, sir?
Yes, that depends on your computer speed. See, actually, I have the laptop and the desktop. I am using the desktop for the demo. Why? Because my desktop is more advanced than the laptop. Okay, that takes a lot of time. That based on your speed of the computer. Few of you complete it quickly. Few of you it takes some time to synthesize it. That depends on the computer speed. And if your computer is very old one, this Vivado is also not supported. After synthesis, it will ask you to run implementation. Run implementation means this process. Here, as I said, the third level of the design flow, VLSI design flow will happen. Okay, but that is not required as of now. Tomorrow, if possible, I will explain about that. And if you want to see the reports, click on view reports. Okay, don't go for running the next implementation. Okay, open the synthesized design or view reports. Anyone you can choose. Otherwise, you can choose open the synthesized design. Yes. Now, after completion of the simulation, you can close the simulation window. Now, this is here you can see some gates. No, these are all the gates, but you cannot see much about this. Later I will explain you about this. Now you can see the left hand side here. You can see the reports, timing report. You want to see the timing report summary, you can see here. You want to see the schematic, you can click on this. Okay, this is RTL. Okay, that is gate level netlist. Here the technology driven gate level netlist, this one. Okay, inside this lookup table, your logic design is there. Okay, as I said, FECA will have the lookup tables. Inside the lookup table, the design will be there. Now if you want to see the timing the summary, click on this timing summary. Here this timing summary will give you only if you have specified the clock. If no clock, you will get the information of the timing through the reports. Okay, here you can see a utilization report also. It was utilized 1 lookup table and 4 IOBs. You can see here 1, 2, 3, 4 input output buffers, 1, 2, 3, and here 1, 4 input output buffers, 1 lookup table. Now that is for the utilization of the device. Okay. Similarly, power report, if you want to see, you can see the power report also. How much power is consumed for running your program. Now this is the power report. Now at the same time you can see here project summary. Okay, here also you can see the synthesis report. Sorry. Here also you can see in the project summary also you can see the synthesis report. And status. If any violations are there or not, timing, power, and this can be seen very clearly after completion of the implementation. You can get the exact power, how much power is utilized. Okay, now these all are, you can understand if you go through carefully, you can understand for each and every design. Now this is the FPGA core area. Okay. Since your design is very small design, you cannot see where it is placed. But if your system is bigger, then you can see. Okay, by zooming in, you can see in which these all are the CLBs. Okay, CLBs will be having multiplexers. Just I am zooming it. Now this is what, and my webinar also I explained you the concept of CLB. Okay. Now these are some of the reports what you can see. Actually here we have to create the UCF file, but without the board we cannot understand the creation of UCF file. That I will explain you later. After this pandemic over, I will ask the Aruna madam to arrange 2 more days training program where I can explain you how to implement the design and the FPGA board. Why? Because right now I was not having the FPGA board that is there in the college. Okay. Now I am expecting you to practice the remaining programs. Remaining programs is decoder. Next, after completion of this code, go to the decoder. Otherwise, let me explain. See, if you launched any windows, you can see all those windows here. Okay, source window, okay, project summary window, all these things you can see here. At times you may, by mistake, you may close the source window. This is the source window. Okay, and if you want to retrieve it, go to the windows and then you can see here whatever window you wanted to retrieve it, you can retrieve it. Okay, now let us understand how to do the structural. For this I will explain you the concept full ladder. Okay, full ladder will explain you how to program the structural modeling. Okay, now I hope you understood data flow modeling. Any query?
Acronym stands for what? Capital, for example.
Yeah, that percentage is gives the reminder during the, that is we can say modulus operator. Percentage of utilization is calculated based on the number of logic gates available and out of which how many logic gates are used. Now we have taken the jet board. In the jet board, there are
So like what
some gates prescribed, out of which how many gates we are using.
whether you don't know my passport, I got to here. You can post your answer
Hello,
on the chat.
organizer, Aruna madam. I hope you understood percentage of utilization, how it is calculated.
Hello,
Yes,
sir.
sir. Yes, sir.
Yeah. Okay, now let us go to the another program where we can use the structural modeling concept. Okay. Now I am taking the full ladder file, new full ladder. FE I can write, otherwise let us write full underscore adder. That is the design name. Okay, it is asking already name is available. We want now it is asking us to change. Okay. Now I will give the name FA underscore struct struct. Okay, structural modeling we are using. That's why full. Now similar RTL. Then next here, if you want to define the file source file here. Otherwise, after this also you can define, and but ensure that it is Verilog and then simulator is mixed. Language is Verilog and simulator is mixed. Then take the board, jet board. What happened? I think. Then go to the design sources and then add source. Here, if you want to define the inputs, outputs, everything here you can define. Otherwise, go to the next. After create, here you have to give the name. Full ladder you can give, no problem. Why? Because previous one that was name of the project. Now this is the name of the file. Okay. Now finish. Now ports you can define it later also. So I'm closing it now, and then double click on this full ladder. You can see the view full ladder. Okay. Now since I have the program with me, I will be doing the copy and paste. All of you done this. After completion of this, you could see here. Okay, not only simple full ladder, there is plus symbol. Okay, at the full adder plus symbol. Then it is asking question mark. Okay, that indicates that okay, you have used the half adder as the lower level module. Where is that lower level module? That is the what question mark. Where is the program for the half adder? That is what it is asking. Now we have defined the top. Always we can put the top level module. That means in the C language, this is a main file, main function followed by sub functions. Same here also. Here main we are implementing is full adder, and then we write the full adder. And then in the full adder, since we have specified there is one lower level component, that is the half adder. That half adder is appearing here. It's done. Are you able to hear me now? Anyone unmute yourself, then let me know. Praveen?
Sir, there is a question.
Yes, what is the question?
Like before doing the full adder program, I didn't do the half adder program. So what I need to do?
Delete that and then first do the full adder and then add the half adder.
First, we need to complete the half adder. Then we need to start with the full adder.
No. First, always you have to write the higher level.
Okay.
And then lower levels. For stopping the previous simulation, just to close the window, simulation window. So automatically that will be closed. Now after completion of this, whenever you get the this question mark, okay, and then see here, this is the name of the half adder. Okay, this is the instance name. You should not consider the instance names. Instance name is for identification. Why identification? Why? Because here there are two same half adders, but which half adder is first one, which half adder is the next one, that should be understood by this instance name. But a half adder is same for both. So here it is giving you 2. Why? Because here we have defined the half adder twice. And it is not asking R. Why? Because R is primitive. R is primitive. That is what here you could see. The purple color. Purple color indicates the keyword. That's why it is not asking for the R. It is asking only for half adder. Now half adder, go to the sources. How to add the half adder? I'm telling you now. Go to the sources, then create our add design source. Next, click on next. Then here we don't have the half adder, so we need to create it. Create. Otherwise, if you have the half adder, we can add the half adder. But ensure that that name of the module what you have, that also same as the name what we given here. Otherwise, you create and then give the name same. This is whatever name we have given here. Okay, that is half adder. That name should not be different. Okay, then ports later you can define. Now you can see here, now question mark gone, and it is showing some half adder .v file. Now double click on this. Here it is blank. Why? Because I have not defined anything during the initialization of the source file. So now we'll put this. But you, before copying, please understand the code at least. Now this one. Here I have used the data flow modeling for defining the half adder. For the full adder, I have used structural modeling. Now this is the mixed model. That is what fifth coding style. Mixed coding style also we can do. Okay. Now whatever concepts you have seen, data flow modeling is used for the half adder. Then structural modeling is used for. Now full adder is ready. Now let us simulate it. How will you simulate? Just click on run simulation. Now it is showing some errors. I think there are some errors. It is asking to see the read and write permissions. Hello. Have you done this?
Yes, sir.
It is throwing some error for me. Aruna madam.
हाँ
Hello.
sir.
Ma'am, there is a disturbance from your side. Please
Okay sir. Okay.
mute. Yeah, now look at this. This error is, look at this at the line number 28. There is error. What is that error is? See here. Here I have defined the capital A, capital B, but here I kept small b. That is the error it is showing. But it is not throwing that capital A and sorry, small b and capital B. It is just showing the position where error is there. We need to identify. Okay. Now run the simulation. Now these are the small minor mistakes what we do while writing the programs. Now it is done. Now we can see here signals also came, but the signals no need to give. But here what we need to give? Here you can see only the ports of the full adder. Why? Because we have designed the full adder, not half adder. For the full adder, half adder is required. That's why we have written the program for the half adder also. But whatever we are doing the simulation, that is for full adder. Now here we can give the inputs. Force constant 0, A0 I am giving, B1, C also 0 I am giving. After this, run for 10 microsecond. Now you can see the result. See, after running, you can click on zoom fit, so everything will come into a single window. Now see here, if ABC 0 1 0, sum is 1, carry is 0. Else, now you can give one as A as 1. Now if if we give 1 1 0, then what will be the output? What is the expected output? Anyone unmute and then tell me. Sum is 0, carry is 1. If all are ones, what is the output?
Then companies can pick you up for your
Now look at,
skills.
if all are ones, sum and carry also 1. Now these are the intermediate signals. Okay, you can see intermediate signals.
I don't know whether someone is providing an ME in avionics, but if they are, then definitely ECE students are the first.
It's done. Now let us go next how to write the test benches. Did you understand till now? Any query? I have done successful simulation of full adder using the half adders. Please say yes or no.
Yes, sir.
Now take this example. Take this example for writing the test bench. Here I am writing the test bench for the half adder, and I am using this code. You also take the snap and then type this. New project. Project name I am giving HA for testing the typing. Next, new source. Create this source. Otherwise, you can use the half added file, previous file also. Now, since here I have used the structural modeling for XR and end, it is asking me, okay, to define that also. So I have to define now XR1. I'm creating the another file for and since here there are two different low level modules, that's why I'm creating two files. Previously there was only one, that is half adder only. That's why we created only one file. Since here there are two, we have to create two. Otherwise you can write the program directly by using data flow modeling. That means sum equal to AX or carry equal to A and B. That also you fine, no problem. Just here I wanted to demonstrate another structural modeling for you. That's why I'm using this. Now after completion of this, if you don't have the time, just open the previous half adder file. Yesterday you have done the half adder. Okay, just open that half adder. That is also okay. Serve the purpose as of now. Are you getting what I'm asking you to do? Hello? Anyone unmute yourself and then tell me?
Sir, instead of writing new program, yesterday half-adder program for that only you're writing the test bench.
Yes. That's why I'm asking. If they don't have the time, much time to rewrite, let them open the yesterday's half adder, and then I will tell you how to add the test bench. That concept I will tell you.
Yes, sir. Yes, sir. Sir, we can use the option like go to file, open project. Hello. Now, who are doing the simulation, the participants, you can do. If you want to open the yesterday's project, you can go to file. You can go to file, open project, and wherever you are saved your file, half adder, in that the symbol of this Vivado tool will be there now. Just open that. It will be opening your project. That is your half adder. Any doubts? How to open the file?
What, ma'am?
No, no, I'm telling sir like how to open the file, uh, how to open the project as your half header. Go to file, open project. You can even show that sir. Open project.
Yeah, if you want to open the project, previous project, go to the file, then open project, and then these are the files whatever I have created. And if you have created the half header, go there and select this, and then click OK.
Select the symbol one,
Open the
not
previous
the.
project.
Yes, sir.
Okay, half header, then select this one, and then click OK. Symbol one.
Rajendra, he's asking like, sir, nothing is started for the test bench, sir. It is just asked to open the any existed file. That is the yesterday's file as half header.
Yes, sir. Yeah, now I'm going to explain you the how to write the test bench. Okay, now all of you ready with the half header file, whether previous one or the new one. Okay. Now see here simulation sources. Right click on this. See, till now we have written the program for the design sources. Now we are writing this solution source. Right click on that and then select the add sources. Then here you can see add or create simulation source. Previously this selection was here, create design source. Now selection will be here. Again I am repeating, either you can use this here or here. Right click and then choose. Here ensure that add or create simulation source you are doing now. Okay. If you select this, it will go to the design category. But if you select this, then it will go to the simulation category. Then next, here you can add, otherwise you can go to the next. Here add or create. If you have the file already, you can add the file, otherwise create the file. Then here you can give the name, but this name should be different than the module. Here I have given the module name half header. Okay. Now I am giving the name of this source file is simulation file is half header half underscore adder underscore DUT design under test. Like that I am giving. Finish. Okay. Now if you would like to specify input, but for the test bench there won't be any inputs and outputs, but everything we can define inside the one. After completion of this, you could see here simulation DUT. Here you can see DUT. Double click on that. And then you can type this, whatever I have written here, half header. Ensure this will be whatever name you given. Okay, I have given the name DUT, so half header underscore DUT I am giving. Now you can see here remodel. Okay, half header underscore DUT. Now here we are doing the cell instantiation. That means we are calling the half header. Now that is half header. Then DUT is the instance name, and then we are mapping the ports of this test bench to the main half header. Okay. Here we have to test the half header. Then we are mapping the ports here. After that, initial begin, and then you can specify the patterns, input patterns. How many input patterns you wanted to give, that many you can specify. And here we are giving some time gap between. Okay, 50 nanoseconds. Here default is nanosecond. It takes default nanosecond. All of you completed up to this? It takes little time because of your typing. Just type this. Whatever I have typed here, just type this and then save it. Click on this save. If there are errors, that will be thrown here. If there are errors, if there are no errors, then no problem with this. Now here you could see all, okay, half adder. Now this is the top level we are running. If you run this automatically, this will call the half adder. Okay, that is half adder. Then that half adder is having again two logic gates. That is what the structure we have defined here. Now this complete structure will go under the simulation. Okay. After completion of this, tell me, then we'll go to the next.
Now anyone is trying to write your test bench?
Is it done? Hello. Respond anyone?
Yes, sir. Hello.
You okay, ma'am? Is participants?
Participants after sharing the attendance link, na, like nearly 20 people are left. So who are there? Like we need to see based on their interest. Anyone respond?
Unmute yourself, then tell me. Hello.
Hello. If anyone is trying really to write your test bench, any problem you are facing? Is it visible the window to write down your this test bench, or try to copy and paste in the Word file to? I'll show like.
Now for time. Now after this, I will complete my part. After that,
Yes, sir. Yes, sir. After writing the test bench,
automatically file is simulated. After writing the test bench run simulation, automatically it takes the different combinations of inputs.
So the same process.
Now after this, click on Zoom fit. Now you could see here. Okay. First is all input. Both are 0 zeros. Someone carry 0 0. Next 1 1. Sorry, 0 1. Sum is 1. Carry is 0. Next sequence we given is 1 0. Again sum 1. Carry 0. Next whenever you give both ones, 0 1. That is what the input pattern we given in the test bench. Now you can see that here. Here only thing is no need of fetching the input manually. Okay. Aruna ma'am.
Yes, sir.
Hello. Yeah, I have uploaded the tasks. I have uploaded the tasks for the day. Okay, let all of them complete those tasks.
Yes, sir. Yes, sir.
Now, if there is any problem, you can help them.
Yes, sir. Sure.
If you are unable to help, then I will help them. Okay. You
okay,
sir. Practice
okay.
all these.
Okay, sir.
Thank you, ma'am.
Thank you,
and
sir.
any more? Now already it is 3:30. I hope you can you have understood the concepts of data flow modeling, structural modeling, the test benches, and I given you some tasks to do. And now I hope whatever knowledge you have gained today, that practical session knowledge, that will help you to simulate all those tasks. Okay. Then tomorrow we will see some more that is behavioral as well, some finite state machines, and if possible I will tell you how to create the user constraint file where we can specify the input output pin numbers and also timing specifications. Okay, ma'am. Aruna ma'am.
Yes, sir.
Now meeting is open, and if they want any queries you can handle it.
Yes, sir. Yes, sir. I will handle.
I have another meeting to do. Yeah.
Okay, sir. Thank you, sir. Thank you for.
Dear participants, anyone unmute yourself, at least speak. If you are not speaking and if you are not following, then you no use of doing this training.
It is especially for final year students of master stream. Anyhow, you need to do this.
Okay, good. Over to you, ma'am.
Yes, sir. Thank you so much, sir.
Thank you, ma'am. Good day.
Thank you.
Bye, all. I will be online only. Just if anybody face the problem, just ping me. I will help you. Okay. For another 10 to 15 minutes, we will open it.
Yeah? Dr. D. Venkatram Reddy, sir. Feedback.
Do you want to close it immediately, or you want it? Okay, that is up to you. Okay, if you end the meeting, I also stop. Otherwise, let it be. Means I am putting it in mute, and I have another task to do. Okay, I'm moving.
Yes, sir.
Thank you.
Anyone is trying, participant, dear participants. I think today, like sir told, the new task that is which are given in the classroom, simulation, RTL schematics, synthesis reports, how to create the manual test bench. Can you send the link? One second, sir. Ma'am already posted, sir. See. The ma'am, which link you? Okay. Anyone is active?
Link.
Ma'am?
Same link, ma'am. Yours link only.
Okay. Ma'am, like if anyone is active, like any problem facing to write your test bench? So for whichever the task is given, sir, yesterday and today, like shall we try with that? Hello. Ravli ma'am is responding, but none of the students are responding. Praneeth, are you there? Hardly 35 students, and I don't know how many. Yeah, you're writing the test bench. You got it, the results. Hello. Ma'am, Indra madam. Hello. Madam? Madam? హలో
అరుణ
ఏంటి మేడం?
వినిపిస్తుందా?
వినబడుతుంది మేడం. ట్రై చేద్దామా? వీళ్ళు ఎవరన్నా ట్రై చేస్తా అంటే సార్ లైక్ ఎనీవన్
Try to solve the task which is given in the Google Class. వాళ్ళని డౌట్స్ ఉంటే పింక్ చేయమని చెప్తాం.
అదే ఇది అంటే వీళ్ళు ఎర్రర్ వస్తుంది
Respond
అని
అవ్వట్లేదు.
లైక్ ఏమంటారు గ్రూప్ లో పోస్ట్ చేస్తున్నారు. దానికంటే ఇప్పుడు లైవ్ లో ఉన్నప్పుడు వాళ్ళ షేర్ చేసిన వాళ్ళ స్క్రీన్ షేర్ చేసిన బాగానే ఉంటుంది కదా మేడం.
ఎస్ కరెక్ట్.
అది తొందరగా రిజాల్వ్ అవుతుంది. దాంట్లో మనకు అర్థం కాదు.
అవును.
అదే if anyone is having the problem, like you can share your screen like where you are getting the error. Maybe writing the code, if you are having the errors or nothing, but you can see the code and you can rectify it. Other than that code, any other process, select as a top add top module. Like that, if you are having any, we can show here.
If anyone facing some problem, let me know, ma.
Anyone, sir? There is given like how to write even the manual test bench. Tried anyone to write a test bench? I will write any program.
No one having any problem, I think.
No. Yes, ma'am. And Anandi Ishwar, for what, ma'am? It is Anandi Ishwar. Sorry. And I will share our screen or will do some programs. What is the task like? Test bench. Test bench, yes, ma'am. Okay. Test bench. Someone tried.
So, excuse me, ma'am. Can you just demonstrate an entire program, ma'am, which has some other modules like half adder along with test bench, some other program, ma'am?
Other than the half adder, like you want to write.
Other than full adder, ma'am.
Other than half adder and full adder.
Yes, ma'am.
Okay. Is the procedure is not clear, ma'am?
It's not like that, ma'am. At multiple stages, I'm getting errors. So I just want, if you explain, I'll be trying it by myself later.
Okay, ma'am. I'll try my level best. I'm sharing my screen. Is it visible, ma'am? My window?
Yes.
Indra, ma'am, it is showing
Yes,
some
it's visible.
test bench. So
Yes.
I'll go to file, new project. It's project name. Ma'am, we'll try with the decoder, ma'am. Decoder. It's a 2x4 decoder. RTL. Project type is RTL. Go for next.
Hello, ma'am. Ma'am, can you please implement 4x1 mux using 2x1?
Okay.
You didn't ask any specific, na, ma'am. That's why I started with the.
Yes, ma'am. Sorry, I was just going through the task, so I found 4x1 using 2x1.
Okay.
Same as off adder using full adder, ma. There is no difference.
mux 4x1 mux RTL project. Next, create file mux 41. Okay. Next, constraints are optional and try to add your Z board. Next, finish it. Would you like to close it as? So 4x1 mux. 4x1 mux. How many inputs we required is 4 inputs.
Directly write the inputs in the program itself.
Ma'am, buses will include or will write the I0, I1, I2.
2x1 kada 1 bit.
4x1 using 2x1.
Okay, okay. Take bus.
I0. Bus much. I1, I2, I3. Inputs
S0, S1.
S0, S1, and outputs are Y. Y is your output. Okay, ma'am. Okay, change, we'll see. Practice. 4x1 using 2x1.
2x1.
So mux 2 1 M1. So normally 2x1 mux it requires 2 inputs. Is it not? 2 inputs, 1 selection input and 1 output. Is it no, ma'am? So out of these 4 inputs, I am selecting 2 inputs for the first 2x1 mux. Okay, ma'am? I will draw first the diagram. Two by one mux.
Three 2x1.
I2, I3. Yes, ma'am. 3 2x1 mux. Now, I0, I1, 2 inputs and first one I think S0, S1. S1 ma'am. Selection inputs. S1 comma intermediate output is Y1. Copy and paste the same for 2 more times. Copy. Paste. It's M1, M2. The modules are 3 different modules, so module names should be different. M1, M2, M3. I0, I1, S1, Y1, and it is I2, I3.
S1
Selection is S1 only, but the output is Y2, and inputs, whatever the outputs we are getting for the first 2x1 muxes are acting as inputs for the next mux. Y1, Y2. Selection input is S0, and finally we got the output as Y. So try to indicate your intermediate outputs, that is Y1 and Y2 with the whites. Is it no, ma'am? The other all are we declared. Okay, try to save this. You'll get here the question marks. What is the question mark? Try to define 2x1 mux. So right click, add sources, add or create design sources. Next, create file. The file is we are creating is 2x1 mux. Okay, and finish. Add this file. So So the ports we need
డైరెక్ట్
to
ప్రోగ్రామ్ లో ఇచ్చేసే ఇన్పుట్స్ తీసి
ఓకే మేడం, అంటే ద స్టెప్స్ వీఆర్ ఫాలోయింగ్ ఇది కదా, ఒక్కసారి ఏదో ఒకటి ఎక్స్ కమా వై ఇచ్చేసాను. ఎక్స్ కమా వై ఇన్పుట్స్, సెలెక్షన్ ఇన్పుట్ ఎస్, అవుట్పుట్ ఈస్
జెడ్
అవుట్పుట్ ద సేమ్ సీక్వెన్స్ కదా మేడం ఇచ్చింది. ఓకే. So if you just click on this, we'll get our program. That is, you need to write the logic for your 2 by 1 marks using, I think we can try data flow model. It will be easy out.
అసైన్.
Okay. Assign. It's a continuous assignment operator for writing the programs in data flow model. Out is equal to negation of S. Negation of S and
ఎస్ ఆర్
R S and the next input is B.
వై వై.
Okay, sorry, X comma Y. X comma Y. Okay, this is your file. So we can do the simulation directly, ma'am, because if the simulation is okay, like we can go for writing the test bench or anything we can do. Correct, na, ma'am? Run simulation. If the simulation window is not at open, is nothing but we are going to have some errors. Okay, simulation window is open. So here we need to provide I0, I1, I2, I3, S0, S1. Intermediate signals no need to indicate. So what is the force constant is 1. Force constant is 1. Force constant is 1. Then I3 I will give it as the input as 0. S0 value is 0. Constant S1 value is also
1
0.
పెట్టు.
0 0 ఒకసారి చూద్దాం, తర్వాత లాస్ట్ 1 1 పెడదాం.
ఓకే.
0 0, then go for your simulation for 10 microseconds. What is the output bar? Output y is equal to 1 because 0 0 is nothing but I0 will be selected. So I'll change it to the selection inputs 1. Force constant is 1. So now I change my selection inputs as 1 1 is nothing but it is going to select the I3 as your output. So my output will be equal to 0. So here this is the zoom fit option. It is going to give all the combinations of your input which you are given, which are applied for this test bench. If once these are okay, you can go for your RTL schematic. Open schematic. Okay. Then open schematic, then synthesis reports, and how to generate manually the test bench. These are the steps we are seeing till now today. So I think we use 3 muxes M1, M2, M3. Is it number? S1 is common for M1 and M2, and the inputs are I0 and I1, I2, I3. The outputs of the first mux is acting as the input for the last M3 mux. Output of the second mux is acting as input for the last M3 mux. Selection input is S0, so your output is Y. So after schematic, you can see for the synthesis, run synthesis. Okay. I think for synthesis, it is taking some time. Sir told now based on your hardware, like what capacity and your speed and memory, how much it is going to take place depends. So if your RAM is of like good like GB of some 8 GB or 16 GB, then it is mine is only 4 GB. It is going to take some little amount of time. I think this top corner you're going to have it's a running synthesis design. Something is going to do. Ma'am, which one? Ma'am is asking now. Ma'am is there. Ma'am, is the steps are clear? I think tomorrow we can see till now. I think it is of all the designs are of combinational designs. You can see tomorrow it's a sequential design using the clocks. So we don't run the simulation. Mu reports are enough for us. It's all the reports are there. Device utilization. Even sir told that if you want to see the reports, you can even see. You can see the window. It's a project summary. It's a complete view. Default reports. Ma'am, here we'll open the reports. I think for each and every reports are opened like here only, no, ma'am? Yeah, ma'am? Report summary. Total number of endpoints. I think the window. Okay, na, ma'am?
Hello, ma'am. Can you please explain test bench, ma'am? Till here, everything is very clear. Can you please explain test bench?
How to manually write the test bench.
Yes, ma'am. Yes, ma'am.
Okay, the sources. I think the already the simulation sources are there. This is created by just clicking the run simulation. So if you want to generate the manually simulation sources, right click, add sources. We need to add the simulation sources. So it is already selected simulation sources. Next, so simulation sources create file. I'm just using its mux41 underscore test bench. Okay. So finish. So what are the inputs? So I'm not selecting any one of the input and output. It's S. So here you can see I just created mux41 underscore test bench. Manually it is created. So uh, whichever the inputs you are indicated in the design, which are indicated by reg. In the case of test bench, so what are the inputs are given? It's I0, I1, I2, I3, and even the
It's not S.
selection input as S0, comma S1, and the outputs are indicated by Y. What is the output is Y, I think. Correct, no, ma'am? Y.
Yes.
Then you need to design under test. You need to add its mux 41.
You're instantiating your design block in a test bench.
So you're adding your design block for applying for
Inputs.
compatibility of your inputs which are defined in the already what we are defined. The test bench inputs are very similar to your design inputs and outputs. Design for testability DUT.
UUT.
DUT and dot I naught of I naught. Okay, Nama.
నార్మల్గా రాశారు నా ఇంకా
ఇది వద్దా అడ్రసింగ్ వద్దా ఇట్లా
అవసరం లేదు నార్మల్గా రాసి I0,
వచ్చేస్తుందా I0, I1,
2 ways కదా పో
2,
డిక్లరేషన్స్.
I3,
S0, S.
నాట్ రాస్తున్నాను S1,
Y.
Y.
Output అంతా
Y. Okay, then initial
begin.
and providing the combinations for I0 with the bus ఇస్తే ఈజీగా ఉండదు కదా ఇప్పుడు తెలుస్తుంది I0 ఈక్వల్స్ టు 0, I1 ఈక్వల్స్ టు ఓకే అక్కడ 111 ఇచ్చినాం కదా సేమ్ అదే ఇద్దాము సెలెక్షన్ ఇన్పుట్స్ చేంజ్ చేద్దాం I0 I1 1, I2 1,
I3 0.
I3 equals to 0, then S0 equals to 0, S1 equals to 0 with a delay of some amount. The delay is hash followed by some amount of delay, and I'm changing the selection inputs. S0 equals to 1, S1 equals to 1.
End.
Okay, only two combinations I just provided. It's end, then end module. So try to save this and again do the same.
క్లోజ్ చేసి
Run behavioral simulation. Again we'll get one more window, correct ma'am? This is the previous simulation is going to be closed or open. Already previous simulation ఉంది కాబట్టి
అవుట్ ఆఫ్ ఇట్.
సో I think okay we'll change the combinations కావాలి అంటే కరెక్ట్ మ్యామ్ అదే వచ్చింది అని అనుకుంటే ఇక్కడ వేరే చేంజ్ చేద్దాం కదా
ఇంకోటి ఇవ్వు లేకపోతే కాపీ పేస్ట్.
ఇక్కడనే కాపీ పేస్ట్ చేద్దాం కాపీ పేస్ట్ S0 తీసుకోము S1 0 ఇవ్వనా సేవ్ it's asking for reader. I think we'll get 3 combinations. It's 0 0. First one is S1 is 0 0. You got the output as 1 because I0 is applied as the input.
Zoom out. చాలు
తర్వాత S0 S1 as 1 1 is nothing but I3 is provided as the output, so output is 0, and then S1 is 0 and S0 is 1. 0, 1 is nothing but, ma'am, it's I1 is going to
S2.
be connected as, that is 1.
S1.
S1, S0 order అట్లనే ఉంటుంది కదా మేడం. S1, S0. So 0, 1 అంటే I1 is selected. If you want to change even, I will change my I0 to 0. Okay, ma'am. Save this. Okay, see on the window. Run simulation. Run behavioral simulation. Yes. I just change the input value. Save it. Okay, okay. అంటే ఇది
Test bench.
we need to go for test bench to change the value of test bench. I1 is 0.
Amrita, is it clear?
Yes, ma'am. Ma'am, is there any need to write test bench even for 2x1 mux?
No need. If you want to see the simulation, then you have to write.
If it is like new for you to test for the for input combination, you want to see the outputs, then you need to write a test bench. Check the subblocks are correct, then only your top block top module will be, anyway it will be correct.
Okay, ma'am. Thank you.
0, 1. So output, I think it is taking I2 only, ma'am. See, S0, S1, 1, 0. I2, Y is 1. Indra madam. కదా S0,
మనం
S1.
రాసిన దాన్ని బట్టి ఉంటది కదా S0, S1. ముందు మక్స్ కి ఫస్ట్ రో మక్స్ కి సెకండ్ రో మక్స్.
ఎవరన్నా ఉంటే అంటే try to do, if any doubts like tomorrow if you are going to share your window now, it is very easy for us to resolve the like who are present, the 17 members. I think మేము 2 తీసేస్తే 15 members who are there. Like if you are really interested, as tomorrow we'll wait for some more time after the session. You can share the window if the speaker is present to resolve your doubts. Try to do meanwhile your assignment tasks which are given in the classroom, which are posted. Okay, shall we wind up the session? Okay, ma'am. Okay, thank you for the patience. We'll see tomorrow. Thank you, ma'am. Indira ma'am.